Now, in this lesson, we want to look at an example to the Gauss-Seidel method. We did look at how to set up the Gauss-Seidel method in the previous lesson. We want now to look at an example. So, just like the Jacobi method, we said that we make x1 the subject from the first equation, x2 the subject from the second equation, and x3 the subject from the third equation. If we do this, we have the equivalent system here, and we set up the iterative procedure. You see now, we have for a given approximation xk, we can compute xk plus 1. So x1 k plus 1 will be 1 over 5, x minus x2k minus 2x3k plus 19. In the second equation, we see that for x1 is computed in the current iteration here, so we use that value, the updated value. And in the third iteration, x2 and x1, we use the values that we have obtained from the first and the second equation. So we start with an initial approximation 1, 0, 0. So we have for k is 1, we have x1 to is 1 for 5 minus 1 x2 1 plus or minus 2x3 1 plus 19. We are substituting x2 1 is 0, x3 1 is 0. So when we substitute, we get 0.8. In the second equation, notice that in the second equation, now the value that we use here is the value that we have obtained from here, not the odd value 1, which is in the initial approximation. So we use that value, 3.8. For x3, we still have 0. Then minus 2, we get that value. In that equation, now we use the values that we have obtained from the first and the second. 3.8 minus 1.5. If it was Jacobi, we would still be using the odd values from the initial approximation. So we get this. We go to KS2. And for KS2, we say that we have x13 is 1 over 5 minus x22 minus 2x32 plus 19. But now the value we obtained here, we use it in the second equation. And the value we use in the second equation, we now use it also in that equation together with the value that we get from the first equation. So that we have in the second iteration, we have the solution being this. So we can repeat this procedure many times and still get a very good approximation to the solution. We have example 2 here. Now we want to use 1, 1, 1 as the initial approximation. And you can set up the equations, the system the same way. Make x1 the subject from the first equation, make x2 the subject from this, and make x3 the subject from this one, and set up the Gauss-Seidel. You can look at example 3 also. And example 3, you use both the Jacobi and the Gauss-Seidel methods. Use both the Jacobi and the Gauss-Seidel method to approximate the solution. Now, we shall also be looking at the use of MATLAB in solving these systems. And we shall, because with MATLAB is simulation software that can be used to generate the solutions very fast. So I think we shall do a short introduction to MATLAB, then you can easily use it in solving such systems. So go look at those two examples, example 2 and 3, and then we can proceed from there in our next lesson. But we shall also do a short introduction to MATLAB programming so that we can then use it in solving some of these systems.